afternoon, everyone. We are working on the second part now, section 6.2, right angled triangles, part B, because we split it into A and B because we didn't have enough time. B is going to be the hardest one. It might not have questions that remind you of the sprinkler question, but there will be some quite interesting ones nonetheless. So let me give you a recap on the main go-to guy. If you have a right angled triangle, the angle theta is the angle of interest. The long sloping one is always called the hypotenuse. The one that's furthest away is called the opposite side, and the one that's touching the angle is called the adjacent. And we have three trig ratios that we use I've lost the window, but never mind. SOHCAHTOA, and these three trig ratios are the sine, the cosine, and the tangent. And essentially what these allow us to do is that if you give me a right angled triangle, you only need to give me certain pieces of information, and from that I can find all the other missing pieces. So before we start getting into the sprinkler questions, let's do some of the more straightforward ones, which is kind of overlap from last time. So for instance, if I give you a right angled triangle, which that horrible mess is meant to be, and I put this angle here as theta, and I tell you that's 10, and I tell you this is 4, and I ask you to find the size of angle theta. Right, so your question is, how do you find a missing angle when you know two sides of a right angled triangle? And the way that we approach this is we name the sides. So you're going to do that no matter what the story is. So from this angle's perspective, the 10 is the opposite, the 4 is the adjacent, and this guy here that doesn't have anything on it will be the hypotenuse. You then go through your list of sine, cosine, and tangent, and you choose the one that uses things that you know or are trying to find out. In this case, I know the opposite and I know the adjacent. That tells me that the formula that I want to use is the tangent, because that's the only one that uses opposite and adjacent. So far, so good? Now, the tangent of the missing angle then is going to be 10 over 4, which I could turn it into a decimal. I'm just not going to. Now, how do you find the missing angle? Well, thankfully, because it'd be very hard any other way, the calculator has a feature that allows us to find the missing angle. And the guy that you're going to use is called the inverse tan function. And so it basically will tell you what angle has a tan of 10 over 4. Now, to get to it, you do, in my case, this button here, the second button, followed by the tan. You see it, inverse tan. By the way, that -1 has got nothing to do with reciprocals or negative powers. It's to do with inverse functions. If you remember in 141, f inverse x. So I just type in 10 divided by 4, and I have the answer. Well, right now that's a bit suspicious to me because it's quite small. So I'm going to go in and check my mode. And most of these questions right now are going to be in degrees. So there's a little thing to check. Make sure you're in degrees. And now I'll go back out and I'll do it again, inverse tan of 10 divided by 4. And now I have, would you agree that's a much more normal kind of answer for an angle? About 68.2 degrees if it was to 1 decimal place. When you're doing these questions, will you make sure that you read the accuracy that they want? 1, 2, 22 decimal places, whatever it was, you would do that. But that's essentially how you would find a missing angle. Question?
Yeah, so I was using just putting it in degree mode and just entering in without the inverse basically. And I think I was just getting the radians from that, but or I don't really know. I guess I just misunderstood. I might have been doing it wrong this entire time, but I thought that was giving me the correct answer, not using the inverse.
You need to use the inverse. So if you were doing anything else, I'd be, yeah, it just basically wouldn't work.
That's probably why it didn't work for me either. I was having issues and I didn't know you were supposed to do that.
Well, hey, we've solved something here today. Are we comfortable with it now then? You have that extra little inverse button.
Thank you.
Okay. Now, there is a second basic question that you're likely to see, and it'll look something like this. This angle here is, say, 31 degrees. And this side here is 12. And you're being asked to find a missing side. So this is a right angle triangle where you're given two sides and you're being asked to find an angle. That's essentially how we're going to solve that one. And this one is you're given two sides and an angle and you've been asked to find x. And they pretty much follow the same kind of process here with a little change at the end. From the angle 31 degrees perspective, would you agree that this side is called the opposite and this side here is called the hypotenuse? Which one of the 6 trig ratios use an opposite and a hypotenuse?
Cosine?
Okay, is it cosine?
Opposite. Oh, sorry, sine.
Good. So I'll just put the general version down. The sine of theta is the opposite over the hypotenuse. And then I'll plug in what we know. It's the sine of 31 degrees. And this is going to be the opposite over 12. Now, you want to find x here. So you do a little cross multiply thing, and x is 12 times the sine of 31 degrees. And in this case, you don't use the inverse button. I wonder if that's what you were talking about earlier. So in this case, it's 12 times the sine of 31. Do you see? And that might mean, if that's what you're talking about, do you see in this case, to one decimal place anyway, that the answer was 6.2. So when do I use the inverse button? When I'm trying to find a missing angle. When do I not use it? When I already know what the angle is. You see that these are slightly different types of questions. I can't remember who it was, but whoever it was, when you were saying you weren't using the inverse button, was it because it was one of these questions?
I don't think I ever ran into a problem where I had to find the missing angle where I couldn't use like one of the formulas that we had.
Okay.
I don't think I've used that.
Right. So that's maybe because they were special angles like 30 degrees or so, and that it's hard to imagine. Right. So that's how you find missing angles. This is basically how you're going to find missing sides for really ugly numbers. So what we're going to do now is look at puzzles where the picture gets more and more difficult. So this is a version of question 1. And you're going to have a triangle that looks like this guy. And this angle in here is 60 degrees. There's my right angle. This angle here is 30 degrees. That's my guy. We are looking at this side here is going to be 84. Right? That's that distance from there to there. And we are eventually going to find a missing side. There we go. This distance from here to here. Now, these are puzzle questions. And that means that you have to kind of, you have to work on them, right? They're almost unique, right? Each question is going to have its own little idiosyncrasies. One of the common features with this type of question is that you're going to have either a story or a shape that's made up of 2 or more triangles stuck together. Now, I might be asked to find that, but that's actually not who I'm going to find first. I can't do this in one go. What I'm going to do instead is I'm going to find that distance there. And that would correspond to here to here. Okay? Now, let's just pretend for an argument's sake that that ended up being 50, just for argument's sake. What I would then do is I'd find the distance from here to here. See that little guy there? Now, if this big distance is 50, and then I find out that this little distance is 10, won't the guy I want to be 50 take away 10? I would get the answer 40. Do you see the thought process of how I'm going to get this? That's the pathway to solution. Does that make sense? Okay, let's go for it. From this angle's perspective, won't this side be called opposite? And this side here is going to be called adjacent. So I need to find the trig ratio that uses opposite and adjacent, and that happens to be the tangent. So the tangent of theta is the opposite over the adjacent. So the tangent of 30 degrees is 84 over the adjacent. Now, you typically do a little cross multiply here. If I do a cross multiply, I end up having the tangent of 30 degrees times the adjacent, that's that direction, equals 84 times 1. And so to find the adjacent, I divide both sides by the tan of 30. Are we good with so far? Right. Now, once you get to there, then you go 84 divided by the tangent of 30. And the answer I get, how much accuracy do I want? To 1 decimal place. So I'm going to do this to 2 just to be extra safe. So that's going to be there. So I now know that the green distance, right, this distance here, is 145.49. Now what I'm going to do is I'm going to look at this baby triangle here. That's 60 degrees. That's 84. And I'm going to find, I'm short of colours, so I'll just do it in blue. I'm going to find that distance, which basically ends up being that distance there. Well, from this angle's perspective, this guy is called the opposite. Oh, and this one is called the adjacent. Seen this before. So I know I'm going to use the tangent yet again. So opposite over adjacent. It's going to be the tan of 60 degrees is 84 divided by adjacent. You do the cross multiply. The tan is 60 degrees times the adjacent ends up being 84. So if you divide both sides by the tan of 60, let's see what we get here. 84 divided by the tangent of 60. And it looks like 48 point, well, if you round it off, it's going to be 50. So this guy is 48.50. And this guy is going to be 48.50. And pretty much we've got everything we need to know. To find this distance, don't I take the green and subtract the blue? So X is going to be 145.49, take away 48.50. I guess I should call that 145.5 now, it's rounded off to 1 decimal place. So 145.5 take away 48.5, and the answer is a rather surprising, nice number. Okay, so that was the whole process of how to find that missing side x. And you see it involved us using right-angled triangles and finding pieces that would allow us to eventually get x. Any questions? Are we good? Oh, okay, that went better than I thought. There is a kind of logic to it. If you can understand the logic, the question's not that bad. Agreed? If you can kind of say, okay, I can't get it right away, but if I get this guy and I get this guy, then I can get the guy we want, right? And that's always going to be the challenge in these questions, is having a strategy for finding the guy that you're trying to find. Okay. So let's do a puzzle one. A puzzle one where it's written in the terms of a written story. So this is a version of question 3. You have an 18-foot ladder. Okay. If the base of the ladder is 4 feet from the base of the building, so here's my building, here's the ground, and it's 4 feet from the base, you're telling me that that distance is 4 feet. And then my ladder goes like this, and you're telling me that's 18 feet. Can we make assumption that that's my little right angle triangle there on the side?
Yes.
And the question they're asking, well, there's two, but the first question is, they're asking us, what is the angle of elevation of the ladder? The angle of elevation of the ladder is that angle there, right? So if I looked up the ladder, am I moving 20 degrees? 40, 80, what am I looking at? Right, in this puzzle here, if I just pull out the right angle triangle without the other distracting material, isn't that what we know? And we're being asked to find the missing angle theta. Isn't it basically this question here then? Agreed?
Yeah.
So, anybody want to tell me what name we give to side 4? What name do we give to side 4? This guy here.
Adjacent.
Right. I'm running short of room. Can I just do single letters now? Are we okay with A's and H's around the whole 3-letter deal? Okay. So what's the 18 going to be?
Hypotenuse.
Okay. So if we are trying to find this angle, the one that uses these two is which one? Sine, cosine, or tan uses adjacent and hypotenuse.
Cosine.
Cosine.
Agreed. So cosine of theta is adjacent over hypotenuse. Cosine of theta is 4 over 18. Isn't this one of those questions where you have to use the inverse cosine button? Basically, it's a feature that the calculator has got that will tell you what angle you need in a cosine to get this guy as your answer. So I just go here and I go second button, inverse cosine. There we go. And put in 4/18 and get an answer, and they want it to 1 decimal place. So I make that 77.2 degrees because it rounds up a little bit. Are we comfortable with that guy? Yeah. Would you agree that question is probably a lot easier than the other one was?
Yeah.
Yeah. Okay, now that I know that, the second, that's question A. I'll put it up here because I don't have space down there. Question B wanted to know how far up the building. They wanted to know this distance here. I don't even need to use sines, cosines, or tangents. I guess I could, but I don't need to. Give me another way to find that vertical distance.
The Pythagorean theorem.
Right. So a squared plus b squared equals c squared. So in this case, it's going to be 4 squared plus b squared equals 18 squared. So that's 16 plus b squared equals 324. So b squared will be 324 take away 16. So that would make it 308. And in this question, they do not want the exact answer. They just say, give me the answer to the nearest whole number, okay? So if I wanted to find b, wouldn't I find the square root of 308? And if the question didn't mention any accuracy, then type that in. That's the exact answer. But since they said to the nearest whole number, which is pretty rough kind of rounding off, we get the answer about, well, that would round up, wouldn't it? It would round up to 18. And there you go for an example of a question that was written down in the form of a puzzle story. Are we good?
I have a question.
Yes.
How do you decide, like, for the Pythagorean theorem, like which side is A, B, and C?
Oh, it doesn't matter who AB is, just make sure the hypotenuse is C.
Okay.
So you can call one A and the other B or switch places, it'll work.
Okay.
Just make, yeah. Are we good with that, guy?
Yeah.
Okay. Try to find another puzzle one, but they're hard to find. Here, I've done that one. That was, it's the same as the other one. Oh, here's one. I know I'm jumping around a bit, but that's kind of the way this homework is right now. I'm trying to do a copy of a picture as accurately as I can. This side is 70, and this angle in here is 60 degrees. And then they put a right angle triangle like this, and then it went something like that. This guy here is 65 degrees, and this guy here is X. So it's another one of those triangles with a puzzle in it, right? Now, eventually I'm going to get that distance, but I really am not going to get it right away. So that you can tell me an answer. Which one of those two sides, A or B, will I find first? Remember, my goal is to get X, but what will I do first?
B,
Correct. Why B?
because that's the one side that relates to the other triangle.
Right. So when you've got one of these triangles with other triangles stuck to it, well, you try and think of a side that is shared by both triangles, because that, in this case, is B, and that's the guy you should go hunting for, right? Now, once I know what this guy is, won't this question just be another right angle triangle where I know a side and I'm trying to find the other side, right? So we know how to do those. In fact, this in a way is like two of those questions put together. So I'm only drawing the piece of the puzzle that I need to get that side there. So that's 70. And this is 60 degrees, and I want this side here. So opposite and hypotenuse. Would you agree those are the two that we're going to use? Opposite, hypotenuse. And we are going to find hypotenuse. Which angle, which trick gets you those two guys? Or
Sine.
uses those two guys? So we're going to do sine, agreed. So opposite over hypotenuse, and that's going to be the sine of 60 degrees is 70 over h. If you do that little cross multiply, we get the sine is 60 degrees times the hypotenuse is 70. So the hypotenuse is 70 divided by the sine of 60 degrees. And they want the answers to one decimal place here. So that's where I'm going to go. So I have 70 divided by the sine of 60. And I get about 80.8. That's good. Good start. Now that means that I now know this side here is 80.8. So I go over here. And I mean, I could draw it that way, but I'm actually going to straighten it up because it helps me visually if things are vertical. That guy's 80.8. Over here is the X, and down here is 65 degrees. You're happy about me basically just doing that, right? Now, in this case, it's pretty much the same as the question we just did, isn't it? Because this is opposite and this is hypotenuse. And by coincidence, that is also a sine. And this time it's the sine of 65 degrees. And it's 80.8 divided by x. So you do the little one in the cross multiply thing. The sine of 65 degrees times x is 80.8. And so to get x, it's 80.8 divided by the sine of 65 degrees. So here we go. 80.8 divided by the sine of 65. And to one decimal place, I make that 89.2. Are we good with that? We're finished. Little thing to watch out for. When you do rounding off, as I've done here, if you do all your calculations to a lot more accuracy and only round off this guy, the one at the end, to one decimal place, you might find that the answers end up looking just a little bit different. It's just basically rounding off error. So if you're really certain you've done it right, but WebAssign says that's wrong, why don't you try this or this in case it's just a simple multiple round off? The alternate to doing that is round this guy off to like 8 decimal places and use all the accurate answers to get that. So you might round it off to 80.8, but when you actually do it in the next calculation, you'll call it 80.812227, and that will help this. Normally the rounding off error is quite minute, right? Normally this will just wiggle by a point or two. It won't be that far away. And hopefully WebAssign has a little bit of common sense and would realize that you've done the question correctly anyway, and it would accept that as the answer. Are we good with that puzzle with the two triangles? Any questions before I move on to my next one? Okay. This is going to be the last one of this type, and then we're going to look at a different kind of question in that same section. It's another double triangle one. I've got a right angle triangle. It looks something like this. The right angle is up here. This guy down here is X. Then this guy just basically keeps going like that. And this fella goes all the way up like that. And this angle here is the right angle, whole thing. And this angle here is 30 degrees. And this side here is 9. Okay, pretty messy picture, but the goal is to find angle X. And even if it doesn't look like it, well, you pretend that's a single straight line because it's meant to be. Now, this puzzle is unique. There are at least 2 different ways my brain is telling me I could solve this. At least 2. There's probably a couple more I can't think of. And one of them is really easy. And if you figure this one out, you'll save yourself an awful lot of extra work. Okay, any suggestions about the process? I don't need the details, but how you're going to find X.
Well, first you're gonna find one angle on that triangle.
This triangle here? Agreed. Have you any idea a quick way to find the size of that angle rather than going through a whole load of steps to get to
Well, the triangle has a 90 degree and a 30 degree.
Uh-huh.
That equals 120. So that means the other one has to add up to 180. So the other angle is 60 on the other triangle.
Yep. Agreed. Where I put it there.
That works.
See it? Now, you could put a 60 degree there, couldn't you? And since that's a right angle, couldn't you put a 30 degree there and then get 60? Wouldn't that be another way of coming up with the 60, but it would still be 60?
Yeah, that's what I was saying.
Yeah, so that was perfectly fine way of doing it as well. That's the shortcut way. I guess the long cut way would be to find all sorts of sides and then build those sides into the other sides and, you know, go all over the place. I'm going to deliberately leave this guy that way. And so we know this angle is 60. I could have put the 30, but I'm going to call it 60. I only need one. I know this side here is 9. And I need to find that guy. Agreed? So what do we do next? I got my triangle, I got 9 and I've got X. What do I do next?
Name the sides.
Okay, what's 9 going to be called?
Opposite.
And X?
Hypotenuse.
And which trig uses those two guys?
Sine.
I mean, a lot of logic to this, isn't there? Or kind of do A, do B, do C, like step 1, step 2, step 3. Now, in this case, it's going to be the sine is 60 degrees is 9 over X. You do a little cross multiply, you're going to get the sine is 60 degrees times X is 9. And that makes X, if you divide both sides by the sine of 60 degrees, which you should, that guy. So I'm going to go 9 divided by the sine of 60. And I am looking to, what is it, 1 decimal place? I am looking at 10.4. If you look at all 3 of the two triangle questions, weren't they all a little bit different, even although they ended up all being find the missing side, which was, you know, each one had its own little idiosyncrasies. And that, for some people, that's difficult because it's not like, well, if you show me how to do 40 questions, then I'm good, I can do them, right? I can do the next 100. Tomorrow we'll look at some more of these, but these triangles or double triangle questions. But I want to show you something different. And this is, well, let me show you the first question. I think it's easier to show you a question than to doing the details of it, right? I'm going to, or they are going to tell you the tan of an angle. And it's anything they want it to be. In this case, it's square root of 3. And they ask you to draw a sketch of the triangle. So they want you to draw what a triangle, only given that piece of information, looks like. Right. You don't need to worry about how big or small to make the triangle. That's not what they're after. They want you to just have a triangle where the information that's here is also contained in here. So I'm going to call this guy theta. And we need to figure out what the 3 sides are, because that's really what they're asking. And you might superficially say, it's impossible. All I know is that the tangent of theta is root 3, and maybe I could find out that theta is 60 degrees, but that won't help me directly, at least, especially if that number is more awkward. So I'm not going to write it as the square root of 3. I'm going to write it as a fraction, the square root of 3 over 1. Which one of the trig ratios is the tangent equal to? Which one of the trig ratios is tangent? Tangent theta equals.
Is opposite over adjacent.
Now, I'm going to go back to my 3-letter thing again. When you write it that way, can't you then say, well, the top is root 3 and the bottom is 1? And so the opposite is root 3 and the hypotenuse is 1.
It's adjacent instead of hypotenuse.
Oh, darn it. It's opposite over adjacent. I'm too busy thinking in the next line because I was reading that. Right, so opposite over adjacent. So go over here. Opposite, adjacent, hypotenuse. Now we don't want to have any decimal answers. We want these to be perfect answers. So from this picture here, wouldn't the opposite be the square root of 3? And the adjacent would be 1. Would you agree that that's the triangle with 2 of its sides already used? How do you think we're going to get the hypotenuse?
Pythagoras.
Right. And a squared plus b squared equals c squared. And 1 squared plus the square root of 3 squared is c squared. 1 plus 3 is c squared. And you only use positive numbers because these are distances. There's your triangle. This number came out really nice, right? The square root of 4 is positive 2. We're not doing the negative because it's a distance. But can you imagine sometimes it's going to be 5, in which case this will be the square root of 5, and so on. So far, so good? Right. That's a little bit different, isn't it? And once you have got, oops, almost forgot the rest of the question. Once you've got that guy set up, you should be able to find all of them. Okay, so the sine is the opposite over the hypotenuse, root 3 over 2. The cosine is adjacent over hypotenuse, and so that's 1 over 2. The tangent, I guess I could have called it root 3 over 1, but when you simplify it, isn't it just root 3? Cosecant of theta is what you get when you turn that guy upside down, right? Reciprocal. Secant of theta is the reciprocal of a cosine. And tangent of theta, cotangent, I should say, of theta, is the reciprocal of that guy. So far, so good? So if I tell you just that guy, can't you find all 6 eventually? But first, you need to get that triangle before you can do the rest. And then, style points. You don't call things 2 over 1. You really should call them 2. You shouldn't leave things with square roots in the bottom. They don't look pretty. So you want to fix it by multiplying it by a special version of 1. So that guy becomes this guy. So 2 root 3 over 3. And we don't leave fractions like that. It's called rationalizing the denominator. So if you want to get rid of a square root in the bottom, just multiply by a version of 1 that uses that square root. So the top 2 numbers get you that over 3, and that's what this one is. And that's part of what I call style points. Are you comfortable with that process of how that one piece of information allows you to create this triangle, which then allows you to find all 6 answers? Are you comfortable with that? Yeah.
Yes.
Okay, look, good. Let's try it out. I'm going to give you a trig ratio, and you are going to make that triangle, find all the sides, and then get these 6 guys. So that's a fairly big question. So here goes. The sine of theta is going to be 3/5. Don't know. I'll give you 3 minutes. That's not a lot of time. 3 minutes to do the triangle and all 6 ratios. Go for it. Now, no rush. I'm just setting up the template because you pretty much do the questions the same way. all shushed. Sorry about that. My dogs have heard something. Okay, about 10 seconds. Okay, if you've not finished, you can obviously catch up as we go through. Since I've got a sine of theta is 3/5, which of the trig ratios does that one? What does a sine?
Opposite over hypotenuse.
In this particular case, you do have a fraction, right? So you don't need
Not
to do
sharing
much.
your paper.
Oh, sorry. Have I not been sharing for a while? That made it a difficult
No,
question.
you just recently turned it on.
Oh, okay. So here we go. So opposite over hypotenuse. We know the top is 3, and we know the bottom is 5, so we get that. If you actually, I made this dead easy, isn't it? A 3, 4, 5 triangle.
Yep.
Yeah. So you can do the Pythagoras over there. Now, if you want to get a sine, you do 3 opposite over 5 hypotenuse, so that's 3/5, which we already know. And the cosine would be 4/5, which we already know. Well, now we do. And the tangent would be 3/4. And won't this just be reciprocal? Reciprocal. Reciprocal. So you didn't have any tidying up to do because nobody had the square root. That feel good?
Yeah.
Right. So there's 2 more questions in the homework like that. I'm not going to do all the question, but I will do the start up because they are just a little bit trickier. So here's the first one. The cosine of theta is 4/9.
You're not
Sorry.
showing your paper.
I wonder why that keeps doing that. I'm not sure what I'm doing wrong. Keeps on kicking out. There we go. Okay. The cosecant of theta is 9/4. And find all the other guys. Now, when you look at the trig ratios, the ones that we typically do are the sine, cosine, and tangent, right? And there's one bit of paper with those guys in. And so this one, you have to think a bit harder. What's the cosine the reciprocal of? Let me start with that.
Cosecant.
Cosecant, right? So the cosecant is the reciprocal of who? What's the upside down version of?
4/9. Oh,
Correct. Yeah.
fine. Yeah.
So if you think about that one, isn't the cosecant the upside down version of him? That's my question that wasn't as clear as it should have been, right? It's that guy. Or you could just say, if the cosecant is 9/4, doesn't that make the sine 4/9, which is, I think, is what you were saying.
Yeah.
Right. You know, both of those are telling me the same thing. So whatever one kind of makes more sense to you. Because once you've got that, can't you then do theta? There's your opposite, there's your adjacent, and there's your hypotenuse. If I use this version, opposite is 4, hypotenuse is 9. And if I use this version, hypotenuse is 9 and opposite is 4. Do you see they both work? And then won't you use Pythagoras to get an ugly square root that goes here? And then off you go. And that would be essentially a version of 6. And question 7 gives us a cotangent. Okay, I won't even do anywhere near as much as that one. The cotangent is the upside down version of who?
Tangent.
So if I wanted to just write it like this, couldn't I say adjacent over the opposite? And if you tell me that the cotangent is 8/7, don't I know what the adjacent and the opposite are, and I can make my triangle? Are we comfortable with that head start? It just basically is like the other two that we did earlier. That's the end of that special group of questions. And now we're going to look at another group of special questions. And these are called the standard triangles. There are two standard right angle triangles. One of them looks like this. And it's 1, 1, square root of 2. I'll put the theta there. Now, this triangle, this right angle triangle, has two sides that are the same and the hypotenuse is √2. That's the shape of it. What are the sizes of these two angles? This one here and then later on that one over. What size would you expect in degrees if the two sides are 1 and it's right angled?
45.
30 and 30.
Well, two numbers the same, but both 45s because they have to add up to 90. So,
Oh, yeah.
yeah. So 45 degrees goes here, and I'll draw this a little bit bigger, and 45 degrees goes here, and it's 1, 1, √2. And that is one of your two standard triangles. Now, the second standard triangle looks like this. And in this triangle, this guy is 60 degrees and this one is 30 degrees. And we call that, right, a standard triangle as well. Now, if you can memorize what these two triangles look like, you can actually create all the trig ratios for 45 degrees, for 30 degrees, and then for 60 degrees, right? You can create all of those guys. So I'm going to do a little table, and here is X. And here is going to be the sine. I'm calling it X. I guess I should call it theta because it's missing an angle. Theta. We're going to do the sine, the cosine, and the tangent.
I
Now,
think
there
you gave this to us last week.
I did. You're right. I'm having deja vu. Did I give you the triangles as well?
Not the triangles, just the chart.
Good. So that's the new bit. So if you wondered where they came from, these guys do it. So that's going to work pretty well. So I'm going to do 45 degrees. I know it's slightly out of order, 30 degrees and 60 degrees. So I'm only going to get those guys. The other ones like 0 and 90 degrees, couldn't you just do those in your calculator? Because they always come out as zeros and ones normally, right? They could, or undefined. Now, for this triangle here, 45 degrees, can you trust me? If you call this opposite, you call this adjacent, and you call this hypotenuse, this fella here is 1 over root 2. This fella here is 1 over root 2, and this guy is 1. When you simplify this guy, he ends up being 2 over root 2, which is what you would have got in your last table. Right, let's do 30 degrees then. I forgot what the sine of 30 degrees is. Isn't the sine of 30 degrees opposite over hypotenuse? Can you see that ends up being a half? What's the cosine of 30 degrees? Adjacent root 3 divided by hypotenuse 2. So root 3 upon 2. What's the tangent of 30 degrees? 1.
I'm confused. Why is it
Yes.
for sine of 45 and cosine? Why is it 2 over root 2?
Okay. So are you happy about it being 1 over root 2?
Yes.
Okay. So root 2 over 2 is what it should have been.
Oh, okay.
What's the tangent going to be? Well, that's 1 opposite over hypotenuse. That's 1 over root 3. If I tidy that guy up, it ends up being root 3 over 3. Right, 60 degrees. Sine is 60 degrees. Opposite over hypotenuse, root 3 over 2. Cosine is 60 degrees, or adjacent over hypotenuse. And tangent, root opposite over adjacent, root 3 over 1, which we just call root 3. Right, make sure you got those two guys right. Root 2 is over 2. All the others fit well. So if you're great at just memorizing tables, do this. If you're a visual person, couldn't you just memorize these triangles and then create them when you need them? Right, so far so good. Right. Any questions about that table? Although you've seen it before, I've now kind of shown you where it came from. Let's do some questions with it. Suppose you get a question that looks like this. The sine is 60 degrees added to the cosine 60 degrees. Let's just suppose you're asked to do that. And they want exact values. So the cosine is 60 degrees. Sorry, the sine is 60 degrees first, is root 3 over 2. The cosine is 60 degrees is a half. And you can't really do much except that. Suppose I asked you to find the cosine of 30 degrees times the secant of 30 degrees, right? So we want to find out what that combination is and as an exact value. Well, the easy one is the cosine of 30 degrees. The cosine of 30 degrees is root 3 upon 2. Now, if I wanted to find the secant of 30 degrees, isn't the secant the reciprocal of the cosine, right? The upside down version of a cosine. Well, if the cosine is 30 degrees, won't the secant be the upside down version of it? And if you take these two guys and multiply them together, something really nice happens. What's the final answer to this fraction
1.
times that 1?
0.
Well, it's 1 or 0. Look, which is it? It's multiplication. We're multiplying them together. See, it's 1.
1, yeah.
Yeah, top and bottom's the same. Now, you can do all sorts of combinations. I'm going to pick my own because they've got theirs and I want to pick mine. Suppose I said to you, I want to get the sine of 30 degrees multiplied by the cosine of 60 degrees, and it's going to be divided by the tan of 60 degrees. So you just get the numbers from this table. So the sine of 30 degrees is a half, multiplied by the cosine is 60 degrees. Wait a minute, the cosine is 60 degrees is also a half. And the tan of 60 degrees ends up being root 3. So far, so good. And do you think that's the way the final answer should be written?
No.
You want to give me suggestions to make it prettier? Anything you could do just to make it a little bit nicer?
Well,
You don't.
1/2 times 1/2 is 1/4.
Okay, let's do that. That's a good start. Agreed. Does anybody know how to combine a fraction where the numerator is a fraction? It's not too difficult.
Multiplied by the reciprocal, so it'd be 1/4 times the square root of 3.
Yeah,
times-
it'd be that again, right? Agreed? I think of it like this. It's like a quarter times that. Right. Now, again, that's much better than it was a while ago, but it can be tidied up just a little bit more. What special version of 1 will make this fraction look a little bit nicer?
Root 3?
Root 3, yeah. And the top ends up being square root of 3, and 4 times 3 gets you 12. Would you agree that's as good as that answer's ever going to be? So as long as they stick to 30s, 45s, and 60s, can't you use the fractions from this table and multiply them, add them, divide, whatever you've been asked to do, and come up with what that combination would be equal to? And for the last question for today, well, keep that handy. The sine of 30 degrees times the cosine of 60 degrees plus the sine of 60 degrees cosine of 30 degrees. Okay. What is the sine of 30 from this table?
1/2.
Okay, what's the cosine of 60?
1/2.
Okay. Sine of 60?
Root 3 over 2.
And cosine of 30?
Root 3 over 2 again.
Yeah, do you see that it's just by coincidence the answers end up being, well, these two get me a quarter. And if I multiply root 3 by root 3, don't you get 3/4? And wait a minute, you can add these together and don't you get 4/4? Hey,